everyone, welcome. I hope you are doing well. So today I'm going to explain the Unit 4 test part 2, the graded assignment for analytic geometry. So let's take a look at the first example. It tells you that estimate the area of the irregular shape, explain your method, and show your work. So this is the irregular shape that we have here on the coordinate plane. As you can see, it doesn't have straight lines. It's not a regular polygon. So what we're gonna do on your end is gonna help you out. Let's take a look at which ones. The only thing you're gonna do is count, right? So let's take a look at what figures. This is gonna be an approximation. So let's say we can create squares, rectangles that are completed. So let's take a look at this. So maybe I can create here, can create a rectangle, right? So I can create a rectangle here, or even I can go longer here. There you go. Perfect. So this is what you're going to do. You're going to shade rectangles, squares, anything, and then you're going to calculate the area. So let's take a look at this rectangle. Its base, the formula for the area of a rectangle is the base, which we have 1, 2, 3 units, times the height. So 1, 2, 3, 4 units. So the area is going to be, so the base times the height. So the base is 3 units times 4 units, right? And this one doesn't specify centimeters, meters, but we're just going to put square meters. So area equals 4 times 3, 12 square units. Okay, so I already calculated the area of this part. So on your own, you're going to do approximations. Okay, for example, which other one can I complete? Well, I can do this other one, right? To this part, I create another rectangle. This one is 3 units, right? Just 3. I just count the number of squares. Then I have 3 there, so I'm going to add. Then I can do another one here, which would be an approximation. Whatever you guys can complete. Example here, I know this is not a straight line, but it's going to be an approximation, right? Here's another one. And the only thing you're going to count, how many do I have? 1, 2, 3, 4. So I'm going to write here 4 units, right? And then you're going to be completing the rest. So maybe I can have another one here. And then you're going to add them all. So maybe here I can do 2 of them, right? I know this is kind of half. Maybe you can complete 2. And that's the only thing you're going to do. It's going to be an approximation. Okay, and then here I can complete another one, right? And then that's the only thing you're going to do. Here I have it. And then you're going to add all of them in total. For example, so far I have 4, 7, 8, 9, 10. Plus 10, and you're going to try and add them all, okay? So how many can you find adding? This 2, maybe with this 2 you can add. With this one and this one you can add 1, right? So that's what you're going to do. Maybe with this 2 I can add 1 whole, another one here, right? And you can use different colors so it can help you out. So maybe here I can complete another one, right? 1 whole. And you're gonna, the objective is to complete one whole square. Remember, this is going to be an approximation, okay? I'm not requiring an exact area. So try to complete as many squares as from this 2, I can complete 1, right? And you're gonna add all of them. Okay, the other ones that you're gonna complete is gonna be 1 square, 2 squares. So make sure you complete that, and at the end you're gonna add them all. And then you're gonna explain in your own words what you did. I complete squares, rectangles, calculated area, counted, and you're gonna explain it on your own there. Remember, it's an approximation, not an exact answer. Then problem number 2. It says the coordinates of the vertices of PQR are P negative 2, 5, Q negative 1, 1, and R 7, 3. Determine whether the triangle PQR is a right triangle. So please make sure you're showing your work for this example. And we're going to be using the distance formula. Okay, so the first thing you're going to do is let's take a look at how this will look on GeoGebra. Okay, that's the first thing we are going to do. So you're going to go to GeoGebra, and like I told you guys before, in order for you to show the grid lines, what you're going to do is you're going to go to the top part of settings, then you're going to go to show major grid lines, and then show the axis. Okay, here you go. So you can have the x and the y axis, and you can also have the little squares. Okay, so after that we're going to, let's do this part, we're going to graph our points. Okay, so you guys can have a better idea of what we're going to be doing. Okay, so the first thing we're going to do is we're going to graph those 3 points. Remember, this is a triangle. Okay, so a triangle has 3 sides. Okay, so let's try to do that. Here you have point P, which is negative 2, 5. So we're going to graph that point. We're going to go to point here, and then we're going to go on x to the left, negative 2, and up 5. So my point is going to be here, right? You can see it there. And then Q, which is going to be negative 1 left and up 1. Here you have it. And then we have R, which is 7 on X. Let me just zoom out. Remember that the way you can move, I'm gonna drag it here. There you go. And this one is 7, 3. So 7 on X to the right and up 3. I'm gonna go to the point and then 3. So there you go. I already have my 3 points. Okay, so it's P negative 2, 5, negative 1, 1, and 7, 3. Okay, so this is going to be a triangle. Okay, so you can join your points by doing polygon here. There you go. And we want to know if it's a right triangle. It may look right, like a right triangle. Remember, a right triangle has a 90-degree angle, so your 90-degree angle should be here. Okay, so we need to prove that, but because it may look, but I don't know if it's really, because this might be 89-degree angle, 88-degree angle. So for that, I have to calculate the length of all the sides. Okay, from P to Q, and then Q to R, and then P to R. So let's do that. Okay, so we're going to use the distance formula, which is this one. It says distance equals the square root of x squared minus x1, all that in parentheses, squared, plus y2 minus y1 squared. You may have different versions of the distance formula. As long as you follow the one that is easier for you and do not change the order. Okay, for example, x2 is at the beginning, then y2 should be at the beginning of the parentheses. So don't mix it up. Okay, so we're going to calculate the distance between P and Q. Okay, and x1 and y1 is going to be our first point. Yes, so point P, it's negative 2, 5, and point Q is negative 1, 1. Okay, so we're going to label it. Let's make P our first point. So I'm going to label it x1, y1. Why x1 and y1? Because we're going to consider it our first point. And Q is going to be our second point. Negative 1 is x2, and then 1 is y2 because it's our second point. Okay, then once we have that, we're going to substitute on the distance formula. So D equals x2, here I have it, negative 1, minus x1 minus 2, all that in parentheses, plus y2 is 1 minus 5, and all that squared. Okay, so look what I did here. I did not remove the negative from the negative 1. Okay, you need to respect the signs. Don't forget to do that. So now let's do this part. D equals, we need to combine like terms. Negative times negative, it's positive, right? So I'm going to have here negative 1 plus 2. So we have different signs. You subtract and you leave the sign of the highest number. So negative 1 plus 2 is 1. So 1 squared plus 1 minus 5, different signs. So I subtract and leave the sign of the highest number. So it's going to be negative 4 squared. I squared it. 1 times, whenever square means the number multiplied by itself twice. So 1 times 1 is 1. Negative 4 squared means negative 4 times negative 4. The number multiplied by itself twice. So negative times negative is positive. 4 times 4 is 16. It is not 4 times 2. It's negative 4 times negative 4. And then 1 plus 16 is 17. It doesn't have a perfect square root. So let's check that. You guys can also do it on hand. Or remember, I want for you guys to show your work. But you can also check your answer, right? So I'm going to do square root. I'm going to do it on Decimal Scientific. Remember to use parentheses. So I did negative 1 minus negative 2. Remember, don't forget that negative there. Then square it plus parentheses 1 minus 5 and square it. Okay, now look what it gave me, 4.12. Okay, and if I go down here, it gives me, if I do square root of 17, which is what I got, it gives me the same answer. So square root of 17 is being represented as 4.12, okay, approximately in decimal. So just make sure they're equivalent. And it doesn't have a perfect square root, so I'm gonna leave it as square root of 17. Do not put it as a decimal, because we need the exact measurements in order for us to conclude if it's a right triangle or not. So leave it as square root of 17. Okay, and then on your own, I already did PQ. Okay, on your own, you're going to do the distance of QR. Okay, so I'm going to help you a little bit with this one. So Q is negative 1 and 1, and then R is going to be 7, 3. Same thing, establish your point 1, Q x1, y1, and then 7, 3 x2, y2. And you're going to do the same thing. You're going to substitute on your equation. Just be careful if they're negatives. Make sure you respect those negatives. And if you have questions when you do it manually, do it on the calculator just to make sure it's right. But remember, for the TGA, you need to show your work. So I'm going to help you with that one. And then once you did this 2QR, you have to do PR. Okay, because remember, you're forming a triangle. So you're going to do P and R. So you're going to do this one, You're going to get an answer. All of them are going to be square roots because they're not going to have perfect square roots. Okay, so please make sure you leave that answer. So now the distance of PR. So you can do P, which is -2, 5, and then R, which is 7, 3. Okay, and I already have, so PQ, got a square root of 17, QR, -1, 1, 7, 3, and then PR, which is the first one and third one. And you're going to do the same thing, establish your point 1. I'm going to make this one point P my first point, x1 and y2, r x2, y2. Okay, and you're going to substitute it on the distance formula. Once you have your three answers, you're going to have three answers. For the first one is square root of 17. For QR, you're going to get a distance in square root. Then PR, you're going to get your answer. Okay, once you have the three values, you're going to establish if it's a triangle or not. So for that, you're going to use the Pythagorean theorem. You're going to use a squared plus b squared equals c squared. Okay, remember a and b, I'm going to try to do a right triangle here, are the legs. So this is your 90-degree angle. The side that is always across it is the hypotenuse, which is c, and the other two are the legs. This one can be a or b, doesn't matter, but those two are the legs. Okay, so a and b, you're going to add them, and they have to be equal to c squared. Okay, so for example, what I did here, I got one of the values. So you have here, you have to make sure which one is the hypotenuse. For example, PQ, let's go back. Let's do this. So this one, let's substitute it with another letter. Okay, so you guys cannot be confused. So let me do it here. So we need to discover which one. So -2, this one is P. Then we have point B, which is Q. So just replace it here in algebra, Q, so you guys cannot be confused. And then R is 7, 3. Just make sure you are doing the correct one, okay? This one is R. Okay, there you go. So we need to be really careful of which one is our hypotenuse, okay? So in this case, PQ, which we got square root of 17, is this one, is a leg, okay? PR is going to be our hypotenuse. So I'm going to put it here. This is a leg. Square root of 17 is a leg. Okay. So this one is a leg. Then QR is also a leg, the answer that you get here. And PR is going to be your hypotenuse. Okay. So once you get your three answers, make sure you order them correctly. So let's do PQ can be A. So you're going to substitute square root of 17 plus, remember it's squared. Don't forget the square, okay? Plus the answer that you get for B, okay? You're going to get an answer here. And C squared, so B is going to be, let me just replace it with the answers here. It's going to be QR, that distance squared, equals to PR squared, okay? Make sure C should be PR. Why? Because it's a hypotenuse. And you're going to square it. For example, square root of 17 squared, they cancel out. Because whenever you have a square root in a square, they cancel out and you just have 17. If you want to check that out, look, let's do it here on decimal. Square root of 17, and then I square it. They cancel out because they're the opposite. Okay. So if your other answers are also square root, well, they're also going to cancel out. And look, you get 17 because they cancel square root and number square, they cancel out. Okay, so you're going to do that. Whenever you add both of them, this what you get here should be equal to what you get here. If they're not equal, that means that they're not it's not a right triangle. Why? Because the Pythagorean theorem, you can just use it with a right triangle. Okay, so if it doesn't, once you substitute this 2 and square it, it doesn't give you, for example, 100 equals to 100. If it doesn't, then it means that it's not a right triangle. If it does, gives you an equality, then that means it is a right triangle. Why? Because that's what the Pythagorean is for. If they shows an equality, it's a right triangle. It has a 90-degree angle. Okay? So that's what you're going to determine. You're going to calculate the three distances, the three sides, and then at the end, you're going to substitute with the Pythagorean theorem, and if they're equal, it's a right triangle. Okay? Now let's go into problem number 3. Okay? So this problem is going to be about parallel and perpendicular lines. So the coordinates of the vertices of quadrilateral, now we're going to have a quadrilateral, are, you have A, B, C, and D. And Jorge states that quadrilateral ABC is a parallelogram. Okay? So parallelogram, you're going to have 4 sides, and the opposite sides are going to be parallel. Prove or disapprove Jorge's statement. So I added this additional information. It's not on your TGA. So parallel lines, they're never going to cross, as you can see here, right? They're never going to intercept. And we're going to find the slopes of the 4 sides. Okay? So we're going to calculate the slopes for AB, BC, CD, and AD. So if they give you the same slopes of the opposite sides, that means that they're parallel. Okay? Then perpendicular lines are lines that are going to intersect and they're going to form a 90-degree angle. In this case, the slopes are reciprocal. Opposite, reciprocal. For example, here you have -3 over 1, right? Which is equal to -3. And then you have 1/3. So if I multiply -3 over 1 times 1/3, they're opposite because one is negative and the other one is positive. And they're reciprocal. Reciprocal means that you switch. You have 1/3, you switch numerators and denominators. And if you multiply them, it should give you -1. So -3 times 1, -3, right? 3 times 1, 3. I simplify. -3 divided by 3 is -1. Okay? So if multiply gives you a -1, that means that they're reciprocal and opposite. If they don't give you -1, that means they're not. Okay? So in this case, what we're going to prove is that it's a parallelogram. Parallelograms do not form 90-degree angles. Okay? We're going to graph it right now, and that's what we're going to do. We're going to calculate the slopes. So the first thing I want for you guys to do is graph. That's going to help you a lot. So I'm going to use GeoGebra. I'm going to erase this. And I'm going to create this new quadrilateral. Okay, so let's follow. So our first point is 0, 4. So I'm going to 0 and then up 4. There you go. Then we have B, 4 on X, 2 up. So 4 and 2. Let me just move it this way so you guys are able to see my graph. So 4 and 2. Okay, this is where you're gonna see it. So 4 on X, 2 up. just erase this one that was created there. So 4, I'm going to go to point, 4 on X up to, there you go, 4, 2. There you go. Then we have C2 and negative 1, 2 on X, negative 1, go down on Y, and then the negative 2 on X and 1 up. Okay, so there you go. I'm gonna polygon, use the polygon option. Oops, something's happening. Let me just, careful with your cursors. So 4, 2, 2, negative 1, negative 2, 1. Okay, something was happening with the cursor. And then you're gonna do polygon from this point to this one, 2, negative 1, and then negative 2, 1. Okay, so this is a parallelogram. Okay, it has 4 sides. AB should be parallel to DC. Okay, we should have the same slope. And then AD should be parallel to BC. They should have the same slope. Okay, so let's calculate that. Let's first do A and B, those 2 points, AB. So I'm going to calculate the slope, AB and DC. Okay, so AB and DC. So I'm going to calculate this 2 first. Remember, I need 4 slopes, okay? And this is the formula. y2 minus y1 equal divided over x2 minus x1. So I'm going to calculate the slope of AB. Okay, so m equals y2 minus y1 all divided by x2 minus x1. So I need the coordinates, right? A, I'm going to go back. A is 0, 4, and then B is 4, 2. Okay, so I got my points. I'm going to label which one is my first point, which one is my second point. I'm going to do A, x1, y1, 4, 2, x2, y2, because it's my second point. And then it's much easier, right, to label, to substitute once you label. Then I'm going to calculate my slope. M equals y2 is 2, y1 is 4, and then x2 is 4, and then 4 minus x1 is 0. So m equals 2 minus 4 is negative 2. 4 minus 0 is 4. You simplify, divide both by 2, so it's negative 1 over 2. So that's my slope, okay, for AB. Okay, now you're going to do the same thing. You're going to go and do the next 2. You can do B and C, right? So now B and C. Then you're going to do the same thing, okay? I already helped you out with the first one. You are going to do with BC. I'm going to put it here, BC. You're going to calculate the slope of those 2 points. Then you're going to do CD. So follow the order, CD. And then the last one is going to be the first one and the fourth one. Remember, you're forming sides. So it's going to be A and D. So first and second, second, third, third, fourth, and first and last. So AD. Okay. So you're going to calculate the slope of these 4 sides. Remember, it's a quadrilateral. For the first one, I already helped you out. Slope is equals negative 1/2. You're going to calculate for BC, CD, and AD. Now I'm going to help you out. Which ones are going to be parallel? AB should be parallel. Okay, should be parallel to DC. Okay, this two. So this side and this side, DC. And then AD, this one is a parallel symbol to BC. Okay, so those ones should be parallel. So they should have the same slope. AB and DC should have the same slope, and AD and BC should have the same slope. Okay? Yes. So for example, right now we calculated AB. Okay? So AB, it gave us negative 1/2. Negative 1/2. So when you calculate DC, or CD, doesn't matter the order, it should give you negative 1/2. If it doesn't give you negative 1/2, if they're not the same slope between this two and this two, then that means that they are not parallel. Okay? So this two should give you the same. Okay? And AD and BC should give you another slope that is not the same as negative 1/2. Okay? Should be another one. So these two the same, AB and DC, and AD and BC another slope that should be equal. If it doesn't happen, that so you should have two answers the same and the other two answers the same. If it doesn't happen, if all of them are different, even reciprocal, opposite, then that means that they're not parallel. Okay? And that's it. That's the last part. Make sure you have 4 answers for number 3 and the conclusion explaining why is it a parallelogram or not. The same thing for number 2. You should have 4 answers and explaining why. Needs to be a conclusion if it's a right triangle or not. And number 1, I need for you to show this work and the addition of the area. And that's it. And will everybody have a wonderful day. If you have any questions, please make sure you reach out. Bye-bye.